Welcome back everyone. My name is Sagar and in this video we will be learning about interfaces and the difference between abstract class and interface. So in our previous video we already learned what is abstraction and how can you create abstract classes and where to use them. So here we will learn about interface. So you can define an interface with this interface keyword, and suppose I am writing this runnable. So this is now our interface, but what is an interface? So you can just understand it by the word interface. So what do you understand by this word? So according to me, or when you search on the internet, so interface means that it is a mode of communication between two things, right? But in our programming we just cannot directly say that interface is like an intermediate through which we can communicate. Yes, we can, but we don't have to define it like this. We can just say by using an interface we can achieve abstraction, as well as we can define the behavior of something. So interfaces are used to define behavior, and you can just see they cannot have state. So I will also tell you why they cannot have state. So first of all, let me just provide you some information about interfaces in Java. So first of all, we can define interface like this, and they are abstract. They are used to provide abstraction. So all the methods are by default public and abstract, and they are abstract, so they don't have a body. Suppose this is a runnable function, and I already told you that interfaces are used to define behavior. So anything can be runnable. So this is a behavior. So we can just define a function run. So this runnable interface, and that's it. So now this is our runnable interface that is defining the behavior of something that can run. So what thing can run? A human can run, animal can run, and also machine can run. So this is not a general thing, right? We are just defining this behavior for everything. So this is just like a standard thing. So what we can do is, suppose this is lecture 23, and we can just implement an interface using this implements. So this is the obviously first difference between our abstract classes and interface. So implements runnable, and after that you can see there is an error, and I hope you already know this because we are defining abstract function here. So that means we have to define it here. We have to define the body of this run function so that we can use it later. So inside this you can just see lecture 32 implements method, and here is our run method. So if you already don't know about abstract classes, I will strongly recommend you to go watch that first. So this was our lecture 31, and I will also give you the link in the description. So here you can see we are just extending our class. So shape is our abstract class, and this is another class. So we can extend the properties. And here is our runnable interface. So this is our first difference also. So let me just write it here. This is first abstract class uses extends, and interface uses implements. And also using interfaces we can achieve multiple inheritance in Java. So I already told you about inheritance in our inheritance video. So multiple inheritance is not possible in Java, but using interfaces we can achieve it because we can implement multiple interfaces. So suppose this is runnable, and I am also making it, suppose this is clickable, and I am defining a function click. So after that we can also implement this clickable. So now you can see we are just implementing two interfaces at a time, and let me just implement the method. So you can just see there are now two methods, run and click. But suppose if we have same method, but then what happens for our diamond problem? So that was our diamond problem, and that's why we cannot achieve multiple abstraction, because that was our case when two parent classes have the same method, right? So which method should we call? So suppose this clickable also have run method, something like this, and this is also our abstract method, so we also have to implement it here. So okay, this was already implemented, and this is here. So you can just see this is implemented here, and first of all this is both are abstract method, and that means they don't have any body. And suppose in any case they have body, so also in our Java interfaces we can define a body of all the functions fault, and now we can define here. So suppose I'm writing here runnable, and suppose I have to get this body now. So what we can do is, inside our, let me just remove this click function, and inside our run, so what we can do is we can just access this. So this is of runnable interface, runnable dot. So here we have to access this run method, which is of parent class. Sorry, this runnable is not a class, but it is a parent of this lecture 32, right? So what we can do is we can just use this super and a dot, and now you can see run. So that means super means that is on upper level of some class. So this runnable is of upper level of this lecture 32 class, and that's why we can access it here. And after that we can just use this run, and this clickable interface don't have the implementation of this run, so that's why we cannot access it here. So suppose I am writing it here, super dot run, and this will just give us an error, and that's because this is an abstract function. So you can just see abstract method run cannot be accessed directly. So let me just remove this thing here, and now if we are printing this thing, so I will just show you. You can just see this run function is now inside of this lecture 32 class, and this is not a static function, right? This run function is not static for this lecture 32. So if we want to access this run method inside of our lecture 32, then that is obvious. I think you already know this till now, that whenever we want to access any function of any class, then first of all we have to create object of that class. So new lecture 32 dot run. So here we can access this run method, and let me also print something here, implemented here. So it is implemented. First of all we will do this thing, and that means we have to do this. So first of all we will print runnable, and I will write here inside runnable, and after that we will write here printed here, implemented here. So let me just run this main function. So it is here. So first of all we are printing inside runnable, and after that implemented here. So I hope now you understand how we can define multiple inheritance using interfaces, and this is our second property of interface. So properties of interface I will write here. So here first of all properties of interface. So here you can see if we are not defining anything here, so this, then that means all the functions are by default public and abstract. So I will write here default, by default methods are public and abstract. And after that, suppose I have to define the body of any function, so I can just write here default keyword, and after that I can define a body. So can define a body of methods in interface. So I think most of the famous educators out there will also not tell you about this thing, that we can define a body of methods in interface, and that's because they don't want to complex this thing, or maybe they don't have a clear explanation for this thing why we can do this thing. So first of all here you can see we can define a method body inside of our interface, and this is only possible after Java 8, and after Java 9 we can also define here private functions, and you can see inside our interface we are defining our private functions. So that is also possible after Java 9, and I can guarantee most of the YouTubers, most of the famous educators will also skip this thing, because I think they don't have a proper explanation for this, but I will also tell you. Let me copy this thing, can define private methods. Let me write here using this default keyword. So first of all let me just tell you about this thing. First of all, this point, that by default method are abstract and public. So here you can see this is by default abstract and public, and if I am writing here this will be redundant at public and abstract, and you can see modifier abstract is redundant for interface method. And after this our second point is can define a body of method in interface using default keyword. So let me first remove this. So we can define the body of a method in interface, and not only by using this default keyword, but also you can see by using this private keyword. So private is our access modifier, and if you want to learn about access modifiers, then we also have a video for that. So we can just by default here apply an implementation of any method, and now let me just tell you why. So first of all, suppose our case. So let me also remove this clickable. Okay, so suppose I am writing here this void run method, and this is our abstract method. So first of all, this is our first class that is implementing this runnable interface, and it is also overriding because this is abstract and this should be overridden in all the children classes. And suppose there is also some another class A, that is also implementing this runnable, and for that we also have to implement this thing. And let me just copy this thing for multiple case. This is our class A, this class B, and class C, B and C. So now there are multiple classes that are implementing this runnable interface, and they are just providing their own implementation for this run method. And suppose any case, if I have to now define some another property, some another behavior for this runnable, suppose if anything is runnable, then it is also workable. So workable. Suppose I am defining this, and now you can see there are multiple errors now, and that is because all the now children classes have to define this vocable function for their own, and we don't actually want to do this thing. Suppose there is some large Java project and you are just defining an interface and multiple classes are implementing that interface, and now you have to define a new method for that. So here you can see the same example. We are defining multiple classes, and this runnable interface is implemented by all the classes. And here in our case, if we have to define some another function, then that time we have to then override this newly added function to our all the classes, and here are now multiple errors. So what we can do is, instead of doing this thing, we can just define here default block, default value of this vocable interface, vocable function. So what we can do is working, and that's it. So now that's totally up to you, in which class do we have to implement this thing. So suppose I have to implement it in my lecture 32. So what I will do is I will just write here vocable, and that's it. So first of all, it is calling parent class method, but I don't want to do this. I will write my own implementation. Lecture is working. So that doesn't make sense, but it is what it is. So I hope now you understand this thing, that we don't want to force everyone to just implement the particular method. And in these cases, then we can just define this default keyword, so that we can just define our default implementation of any function. And now you can see there is no error. And if any other class also want to implement, then I can also write here vocable, and it is the same thing. So I hope now you understand clearly why we have to, why we can define the body of functions inside our interface. And this is a very important thing to remember, and you can just explain this thing like this example, the same example I showed you. And this is the reason that we can define a body of our functions, and after that we have this private methods in interface. And now let me just show you the reason. So first of all, we have this default implementation of vocable, and after that, suppose I also have some private method. So private void, suppose I'm writing here working. So I'm printing here something is working, and now I can access this method inside of this runnable interface in the default or any other private functions that this runnable interface have. So this is private, so that means it is only bound to this runnable interface. So I can just access this working function here. So here you can see inside of our this parent class, I can access this runnable dot super dot vocable, and here you can see I don't know the implementation of this vocable interface. It is default, but it is calling some another function. So that means here we are defining our encapsulation. So it is our another fourth main pillar of OOPS that we will be learning in our upcoming videos. So here you can see we are just encapsulating the thing, that working is some another thing. We don't know what is the implementation, so we can just define our implementation here, and we cannot access this working outside of this runnable interface. So I think this thing is little bit confusing, but don't worry, we will be learning about encapsulation in our upcoming video. So encapsulation and abstraction are totally different things, so don't confuse in them. So now I hope you understand this thing, that why we can define private methods in our interface. So suppose we want to access it multiple times. So suppose there is also some another function. This is workable, this is doable. Something is doable, then we can also define our working function here, and we don't have to specify this body every time inside of our all the functions. So that is why we can just define our private functions in interfaces. And after that, now let's just talk about properties. So if we are defining any member, any property of this runnable interface, so they should be by default members are public, final, and abstract. So that means they don't have a state. And if we are defining some integer a, so this is public, and that means we can access it everywhere outside of this runnable, and it is also abstract. So that means we can, sorry, it should not be abstract, it is by default static. So public, final, and static. And of static, that means it is a property of our runnable class, and it is also final. So that means we have to define it in the runtime, in the compile time, sorry. So we have to define it here. So if something is final, then we have to define it only one time. So suppose it is 0 here, and let me just override this run function here, and inside this function, okay, this is already defined here. So inside of this function, what we can do is we can just access this a runnable dot, and now you can see we can just access this a, because it is a static thing, and that means we don't have to create an object of interface, and it is also obvious we cannot create. Remember this thing, this is common, we cannot create object of abstract classes and interface. So you can just write this thing here, but we don't have to actually focus on these things, that we can use abstract classes using extend keyword, we can use interface using implements, but all these things are for your exams and not for actual uses. We are going to focus on conceptual use. What should be your mindset when you have to use an abstract class or when you have to use an interface? So we are going to see this thing, and this is not an actual difference. So also after this, so this was the thing about our members, and let me also tell you that we can also define static methods. So static, and let me also show you that it is a static method, and if it is a property of a runnable interface, that means we can just access it using this runnable dot. Here you can see run method. So if we are accessing this thing, then that means this run method should have a body, or we are gonna just break our code. So if something is static, then they should also have a block of code. Okay, so now that means this is a static thing, and this is a part of our runnable interface and not actually the children's of it. So that's why we cannot also override it here. Okay, if it is a default thing, then we can override it. So I hope now you understand all the differences, how we can define a body using our all these three keywords: default, private, and static. And after that, we can have a private body, a private method, and also static method. So you can just get all these lectures from our GitHub repository. I will just drop down the link in the description. So also let me tell you why all the members are public, and here you can see we can define our private methods, but why we cannot define our private members. So here if we are defining it like this, so this is not a possible thing, and that is because if we are not defining any member, public, final, and static, and that means we are storing here the state inside of our runnable interface, and that will just cause our problem. So if we are just doing this thing, that they should be final obviously, and they should be public obviously, because we have to access it outside. But if we are defining it non-public, so non-final, sorry, so if we are defining it non-final, so Java, I don't have a keyword for non-final, but suppose it is non-final, then that means there are some multiple classes that are implementing this runnable interface. Class A implements runnable, and if we are doing this thing, suppose I am implementing this runnable run, and after that I am accessing this A, runnable dot A. So if it is non-final, then we can also update it here, and we can also update it here inside of this. Okay, so then that means, so it is equal to 2. So then that means this runnable interface have now two values. So first of all, we are defining it here inside of this lecture 32. So then that means a values will be equal to 2, and after that we are updating it here. So then that means runnable dot a will be equal to 1. So then this will cause our problem, and this will just break our consistency in our code. So that means inside of our interfaces we should have all the public, final, and static values. Okay, for static it is also obvious, because we cannot create objects of this runnable class, so that's why we should have static. And I think in future Java can also provide private members, but for now it is not possible. So I hope now you understand all this concept, and now let me just tell you the actual difference between using an interface and using an abstract class. So let me just write it here. You can just use abstract class when you have to define the type, or when you can just use interface when you have to define the behavior. So I already told you this thing, that abstract classes are used to define the type. Then that means in our previous example also, so you can just see we are defining abstract class, that is shape. So then that means we are defining a type, a particular type. We are defining a general thing, that anything that is shape should extend this shape class. Okay, so after that we are providing here an abstraction, and this is not complete abstraction, because you can see there are some concrete methods also. So here you can see we can also store the state. So this thing is also possible, and we just can change this answer thing inside of all the children classes, and this will just break our a little bit of consistency in our code. So you can see this is our first thing, that using our abstract classes we can define the type. and this is what you have to think. If you have to define the type of something, then you can use abstract class and you can just provide abstraction. And if you have to define the behavior, so this is a runnable class, and that means runnable is a behavior. So if something is runnable, then it is a behavior of that thing. So if we are creating a class that is a game, so game can also implement this runnable, and game has its own way to run. And if we are doing a writing here a people class, then people can also run, so people can also implement this runnable. But if we are defining here a people, and this should extend our shape, then that doesn't make sense. Shape is a particular type, right? So I hope now you understand this thing, that using our abstract class, we are just restricting that thing, that we can only define the type. So this is our first actual difference. Okay. And after that, the second difference is we have to use abstract classes for generalizing the behavior, generalizing, and we have to use interfaces when we have to standardize the behavior. So standardize. So I already have a complete article for the difference between abstract class and interface, but it is in Kotlin language, but it is mostly similar to our Java language. So you can also refer to it. I will just drop down the link in the description. So you can also read that article if you want the detailed explanation. So second difference is abstract classes are used for generalizing the behavior. Then that means we are defining a general thing. So if this is shape class, so this is our rectangle class, and this should only implement this draw function. And suppose for our example, so suppose I'm creating here a different example. So a good example can be if we are defining some game. So abstract class, a game. So a game is an abstract class, and we can just define some things here. So what can be the things? So we can just define here time, so total time for a game. And after that, we can also define some abstract function. So abstract functions. So what is an abstract function for a game? We can just define here the total number of rounds. So rounds played. So this can be an abstract function, and a non-abstract function. Normal function can be, what can be the good example for this? We can just define, suppose we are defining here rules. So every game has its own rules, so we can just define it as abstract. So this is our abstract, and this round split will be not abstract, because this can be not possible for all the games. So that's why we can just define right here 0. So if we are just doing this thing, if we are accessing round plays, then by default they will have 0. And if we have to access it in our children classes, then we can also override this thing. But every game has its own rules, so this is an important method to override for all the games. Okay, so I think this is a good example, and we can also create here children class. Suppose cricket, no, not cricket, right here football. So football class is a class, and this should extend. So you can just find all these common differences in any website out there, but you cannot find this thing, this actual conceptual difference, in any video. So you have to understand this thing very clearly. And this football is a class, so it should extend this game class. And now we can just extend, override this rules. So as out, play, good. Okay. And after that, if we have to also implement an interface, so now I am creating an interface playable. So if anything is playable, so it can be either video game, it can be either outdoor game, or it can be also video, right? So a video is also playable, so we can just define here play method inside of our playable interface. So this is now a behavior, and this game is now defining a type. So this abstract class is now generalizing the behavior for all the types. We are just defining this playable interface to just standardize the behavior. So I hope now you're understanding this thing, that how we can use abstract classes for generalizing and interfaces for standardizing the things. So this is now a standard thing, that if we are also creating a class that is music, so it can also implement this playable. And if we are defining a football class, then it can also implement. So if we are doing this thing, if we are extending a class, and we can still implement an interface, so playable. And now it have an abstract method, so that's why we have to override it. So we have now a play function, and we can just override it. We can just write here playing football, and that's it. So this is now our complete structure. We have abstract class, so that's why we can just implement, we can just have multiple children classes of this game. So suppose now I am defining cricket, this should also extend this game class, and now cricket also have some another things, right? So suppose it also have this playable interface and also this runnable interface. So this thing, so now we have to define all the methods that are abstract, so also this method. So now we can just define this thing. So I hope now you understand this, that this is for our generalizing the behavior, and interfaces are just standardizing our behavior for all the things. So if it is music also, then we can also play it like this. And now what we can do is inside of our main method, so let me just remove this implementation, and I can just quickly create a object of football, new football object, and now I can just use this football dot play, or I can also access this football dot time, and I can also update it, suppose 160 minutes, and I can I can I can access this thing play, and I can also access these rules. So that's how you have to achieve abstraction, and I hope this video will clear a lot of things to you. So if you want to also write another difference, then what you can do is, so if you have to use an abstract class, so this will work as a base class, right, for our children classes. So this is our base class, and this is not our actual class. So game is nothing. So we can also write here different children. So this can be our cricket or any football. So this game class is working as our base class, and after that our interface will work as a contract. So what is a contract? That means it is defining some particular rules that we have to follow. So you can just see this is our play that we have to extend for our children classes. That means there is some play behavior that we have to override if any class is implementing this interface. Okay. So you can just directly say if any class is playable, then they should have a play method, and also the implementation of that play method by its own. So like this. I hope now you understand these points, and also this interface very clearly, because this is also the thing that will also confuse you, because most of the educators out there, and even also most top websites, they don't explain these things very clearly, and that's why mostly beginners just get confused in between interfaces and abstract classes. So your interviewer might ask you this thing, that why we can define a body of interface. So we can also do this thing inside of our abstract classes. So how this interface is different from our abstract class. So so for that you can just explain the example I gave you today, and you can just explain abstract classes from our previous video. So you can just watch that out first. So that is it for today, everyone. If this video is helpful, go hit the like button and also subscribe to our channel, and thank you for watching.